I'm back for part 5 of the unit circle pie plate video series. These are the guided notes to start to talk about how radians and degrees are connected to one another. You're looking at your pie plate, which is now quite full of information, and what I'd like you to notice is how we're going to compare the length of a radius to the circumference of the circle. You learn that the circumference is equal to 2 pi times the radius, but now we're going to talk about how pi fits into all of this. Okay, so take the length of your radius. I'm going to do that in red. You don't have to do it in any particular color, but you certainly can choose a color if you'd like. I'm choosing red because that was the color that we used with the Twizzler activity, which was meant to demonstrate the same thing. So I'm taking a length of a radius in red, and I'm going to use a string or a Twizzler or something to see how many times that length in red can go around the circle. I'm having trouble finding a red marker. Hold on a second. All right, these will have to do. So I've got this radius in red over here on the x-axis. And what I'm going to do is measure that length, Twizzler or string or something, along the outside of the circle. And it turns out that I can go one length and get to about 57 degrees right up here, just shy of 60. Another length gets me another 60 degrees, just shy of 120 up here in quadrant 2. One more wrapping of that, or one more reach of that string, gets me to 3, just shy of 180. If I go back around here, 60 degrees farther, I get to just shy of about the 225 mark. One more around, so that gets me here in quadrant 3. One more gets me just past 270. And then the final one gets me shy of 360 degrees. Guess how many radians go around this circle? It just so happens that there are 6.28. 6.28 measurements of the radius will go around the outside edge, the circumference of that circle. Well, what does that mean for us? What that means is that the circumference is equal to 2 times pi times the radius. Well, if I set that equal to 6.28, we get that pi is equal to 3.14, of course, which you all know. 3.14 corresponds to this point right here on the circle. It corresponds to 180 degrees. That is amazing and should blow your mind at this point. Well, wait a second. Pi is an actual measurement that means something in distance? Yes. Pi, mark pi right here at 180 degrees. You could put it in a color or make it bold, because that is one of the enduring understandings that I need you to know for this chapter. Pi sits right there at 180 degrees. Take a moment with that. Now, if this is pi at 180 degrees, at 90 degrees, doesn't it make sense that we'd have half of pi, or pi over 2? Let's do that. Let's call that point right there pi over 2. So at 90 degrees, I've got pi over 2 radians as a distance from my starting point at 0, 0 up to pi over 2, and then down to pi. Right now, we can label this point at 270 degrees. You may have caught on that if I've got 1 pi over 2, 2 pi over 2, that this point down here would be 3 pi over 2. So that is the point 3 pi over 2. So now we can start to connect the angle measurements inside of the circle in degrees with the radian measures on the outside of the circle. For example, 90 degrees, this space in here, corresponds to an arc length of pi over 2. 180 degrees inside of the circle in degrees in here corresponds to an arc length of pi. So I want you from now on to think of pi as being equal to 180 degrees. That's going to be the key about how we go back and forth between radians and degrees and degrees and radians. Okay, that's all for now. We'll tune in again in a little bit.